Yeah, AMR is a really big global public health problem. And the reason for that is that functioning antibiotics really underpin functioning healthcare systems. Things like cancer treatment, surgery, transplant, all of these things really start to become very risky when antibiotics stop working. And antibiotic treatment itself is a key driver of antimicrobial resistance. So inappropriately administered or inappropriately targeted antibiotic treatment worsen the antimicrobial resistance problem by generating more of the resistance mechanisms to the drugs. Diagnostic tests that we use in healthcare, so things like urine culture tests, are widely regarded as key weapons against antimicrobial resistance or the generation of antimicrobial resistance. And the reason for that is that diagnostic tests give clinicians and other prescribers more information that they can use to better target antibiotic treatment. The problem is that those tests themselves are not very well targeted. They're performed in a one-size-fits-all way. And what that means is that they're potentially inefficient, inequitable, and ineffective. So what we did in this study is we used artificial intelligence on real-world healthcare data to personalise antimicrobial susceptibility testing, which is a type of diagnostic test that's performed on urine specimens. So we did that for UTI, or urinary tract infection. And what we were able to demonstrate was that by personalising that test, by individualising it to an individual patient, we could provide better targeted antimicrobial susceptibility testing results, which means better targeted antimicrobial treatment, reduced generation of antimicrobial resistance, and reduced antibiotic-associated harm in general. Yeah, I think what we envisage as following on from this study is that diagnostic laboratories and other diagnostic centres within healthcare institutions could become hubs for the delivery of artificial intelligence-enabled interventions in healthcare. So the idea that this is a secure place where people's data could be leveraged to provide better decision-making in real time for them. So for instance, here we'd be talking about a situation where in a microbiology laboratory, the tests that were performed on a urine specimen could be better directed and targeted in real time, and that information could then be immediately looped back and fed to the clinician to provide better information regarding antimicrobial susceptibility and ultimately, hopefully, better decision making in antimicrobial therapy.